Hi, ladies and gentlemen. So I just want to go through graphing homework one. We're going to do one of the two problems. So I'm not going to do all of it with you or all of it for you, but I do want to go through and explain some of it, making sure that we all understand what's going on. So if we look, that first thing it says is, what does the slope of an xt graph represent? Remember that x is our distance, our position, our displacement. We're going to use those words interchangeably, but if we remember real quick, slope is found by taking the change in y over the change in x, or our rise over run. So if we're finding our rise over run, that really means we're doing our y's divided by our x's. So if we look at an xt graph or position versus time graph, so we take our position divided by time, or displacement divided by time, or distance divided by time. Any of those three work. It doesn't really change anything. But if we take that and we rewrite that in terms of our units, it tells us position, distance, displacement, they're all the same units, which we should know by now as meters. Those meters divided by time, which almost always in our class, we're using time as seconds. So meters over seconds, or we can say that as meters per second. And you should remember from any time in kinematics, whenever we talked about meters per second, we are talking about the velocity. So we're talking about the velocity of our object. Something is moving with some velocity. So now that we know when the slope, we're really talking about the velocity. For question 2, we could even change this to say velocity right here. So we're calculating the velocity at each of these segments. So the first thing I like to do is label my different segments. So I'm going to zoom in. I'm going to label this one 1, 2. Remembering that each time you see a change in slope, you are going to label that a different line segment, a different section. I'm actually going to split this one up right here, right at the x-axis, and that's more important for when we do velocity versus time graphs, but I am going to go with 3, 4, and 5. So now it told us to find the slope or to find the velocity at each of these each of these lines. So we need to find the points for each of these sections. So this first one, we are at 0, 0 meters away from our starting position. So we're at our home, our starting position, and we're at 0 seconds. It's going to travel, this object traveled 60 meters. And if we look at the time, it traveled in 10 seconds. So this one's going to be 10 for time, comma 60 for position. This next section, if we look, is at 15 seconds, and it hasn't changed its position. So 15, comma 60. The one after that is at our x-axis at 30 seconds, and we are at 0 for our y, our position. We're back at our home, back at our origin. Way down here, we are at 40 seconds, and we are at negative 40. And then finally, we travel back to the home. And so we are at 55 seconds, and we're at 0 meters away again. So now that we know our points, we are going to calculate the slope. So if I calculate the slope for 1, it's going to be my y2, which is going to be 60 meters, minus my y1, which was my origin, or 0 meters, divided by my x2, which was 10 seconds, minus my x1, which was 0 seconds. If I keep going with this, 60 minus 0 is 60, 10 minus 0 is 10, and so 60 divided by 10 gives me 6 meters per second, because our units are for velocity. We're going to do that for all 5 of our points. And I'm not going to go through each of them specifically, but the next one you should get a velocity of 0 meters per second. The one after that, you should get -4 meters per second. If we keep going from line 4, we should get -4 meters per second. And then the last one you should get 2.67 meters per second, I believe. Let's double check that one. Yep, 2.67. All right. So we found our slopes. So we did part number 2. And number 3 says for these XT graphs, draw the VT graphs in the space below. So now we have to keep going past that section. We need to draw our own graph for velocity versus time. So time always goes on our x-axis, and we're going to put velocity on our y-axis. The time, we are just going to rewrite our time values right here. So 5, 10, 15, 20, 25, 30, 35, 40. And apparently I didn't space them out correctly, so we're going to have to move them. Oops. Man, struggling. 10, 15, 20, 25, 30, 35, 40. There we go. 45, 50, and 55. So now we have our time values, and they're correct because I can finally figure out how to space things apart. But now that we have our time values, our y values, our velocities. So we need to use these values up here. And these are all constant velocities. So we're going to go up. Let's just go up by 1s, and we'll go all the way up to 6, and we'll go all the way down to -6. So if we go up and down to 6, 1, 2, 3, 4, 5, and 6. So close. And going back down, we have -1, -2, -3, -4, -5, -6. Man, so much extra room down there. So if we're looking, we need to remember that our first line segment 1 goes from 0 seconds to 10 seconds. So if we go from 0 to 10, we should go from 0 to 10 on our time interval again, and we're going to look at that velocity, and that velocity is 6 meters per second. So we need to be at 6 meters per second at 0 seconds. We still need to be moving at 6 meters per second at 10 seconds, which means that every second in between, we're going to continue moving at 6 meters per second. So we have a horizontal line, a constant velocity for the first 10 seconds. So we're going to do 6 meters per second. After those first 10 seconds, the next 5 seconds, from 10 to 15 seconds, our velocity or our position stayed constant, which means that our velocity is 0 because our position is staying the same. So we're going to put a point at 0 at 10 seconds, another point at 0 for 15 seconds, and we are going to connect those dots. We're also going to connect the dots between our 10-second interval because the slope or that velocity did change from 6 to 0 at that interval. The next section, from 15 seconds all the way to 30 seconds, our velocity changed, and now we're at a -4 meters per second. So we're going to go down to -4 meters per second at 15 seconds all the way to 30 seconds. So all the way from 15 to 30 seconds. And we're going to connect these dots. But then from 30 to 40 seconds, it stayed at 4. So all the way until 40 now, we're going to stay at -4 meters per second. So it did not change. And then at 40 seconds, we changed and we went back towards that house or towards that origin. So now we are going to be moving with a velocity of 2.67 meters per second. So we're going to go back up to here as a positive 2.67 meters per second for the last 15 seconds. So then the last step, after we make our stair step looking graph, because our velocities are all going to be constants because we're not curving the lines right now. No curved lines means that our velocities have to be constant values because our positions are increasing and decreasing at constant values. So now the last section says that you're going to write a story about that, making sure that your story talks about the fact that you started at home or you started somewhere. You traveled away from your home this many meters in this much time. You stayed there, and then you went back towards your house and you passed your house, continuing to go 40 meters past your house. And then you turn around and walk back home. So wherever you started, you need to end there, making sure that at some point you do pass that origin or your house or something. So making sure that you're going away, coming in opposite direction, and then ending back. Remember, there are no hills here. This is all just moving forward and moving backwards.